Let's think about this. We have DC, we go to AC, and we come back to DC. You will see why. Remember, in the last round we talked about a battery supplying electricity to a battery bus. Like this. We want to call this our DC bus. And you remember, if you look over time, then your voltage is constant. And here we want to remember the number. In aviation, this voltage is 28 volt, and we know DC just to make sure. 28 volt DC is our aviation DC bus voltage in most aircraft nowadays. Now, as we said in the last round, we can have different consumers here. We typically connect them through a circuit breaker. We have our consumer, close the circuit through the airframe, and that's it. Now, this battery has a bit of a disadvantage because it has so and so much energy available, and it's running down. But you know this from your notebooks, you know this from flashlights, you know this from your handphones. Now, alternatively, we can look into another system which uses another source of energy. It uses mechanical energy. This mechanical energy can come from an engine. And this engine can be our aircraft engine. It can be the turbine engine inside the APU, the auxiliary power unit. It can be a diesel engine in the ground power unit. It can be anything. So, this engine turns a device which we want to call the alternator. And the alternator delivers another form of electricity which we call AC, alternating current. And we feed an AC bus. This is our AC bus. Now, AC works a bit different. When you look at AC over time, we will notice that it is not constant, but changes both its amplitude and polarity. And we can count how many times it changes over 1 second. In our household, this is 50 times. If you go to the United States, it is 60 times. In aviation, we use 400 times. So that means our frequency, I shall use a different color here. Just let me change the color of the pencil. How about this one? Our frequency is 400 Hertz. That means our voltage goes 400 times through this cycle in every second. Now, of course, we need to know the voltage, and the voltage in our AC circuit is 115 volts AC. So this is to remember: DC 28 volts, constant polarity, constant amplitude. In the AC we have a change of polarity 400 times per second, and our average voltage is not a constant because it's changing all the time. Our average voltage is 115 volts. Okay, and we can do the same. In fact, we can do the same as we do at home. We can drive another lamp, for instance, through a protection device again. We have here our lamp, and we have the same effect like on the DC side. Now, the AC side has the great advantage that we can run the engine as long as we want, and of course as long as it lasts and as long as we have fuel to burn. But when the engine does not run, and that may be during maintenance in the hangar or when we park the aircraft overnight or something like this, there is no electricity generation. So we have this very nice DC circuit where we have the battery, which we can use whenever it is charged for very limited time. And we have this very nice AC side where we have lesser limited resources, but not at all the time available. Now obviously there is a certain interest to connect the two to each other. So let's say we use the DC side, the direct current, to start up our aircraft, to crank the engine and get it running, and all the energy we have used from the battery we would like to return through this circuit. So we want to convert the AC, the alternate current on the right hand side, into DC on the left hand side. Now if you want to do this, we quickly look into it, and we will find out that we have two problems. Our number one problem is we have 115 volts here, and we need only 28 volts there. So obviously we have to go and to change the voltage level, which we do with a device which we call transformer. Yes, that's a transformer the same way you have in the movies or in the toy shop. It changes, it transforms, right? It changes here from 115 to on the other side. Now I lie a bit to you, this is not exactly 28, never mind. Good, then we have another problem, and the other problem is that I run out of colors. Well, let's continue with yellow. Yellow no good. I use green. I have alternating current here, and I have direct current here. So I have to change this up and down on this side into a constant current on that side, and I use a device called a rectifier. Yeah. So this is my rectifier, and this one we called transformer. Oops. And then we can take this electricity and put it to that system. So we can feed from the AC side and bring the energy to the DC side. Now for simplification, of course, we put all this into one box, and we call this box Transformer Rectifier Unit, TRU. Okay, now it seems advisable to do the same the other way around. And the other way around would basically involve that we take the electricity from the DC bus. So let's extend my DC bus a bit. Go down here and put it through a system of power electronics, which changes the constant current into an alternating one. And once this is performed, we need to change the voltage of the system again, and from here we can feed an AC bus. Now again, we put this one into one box, and in this case we do just the other way around from here, from the transformer rectifier unit. So we call the whole thing the inverse process or inverter. And that's the way it works.